Now, let's suppose that you had some kind of spacecraft that you wanted to launch away from a planet. And in order to do that, you basically need to have it going fast enough to escape the Earth's gravitational pull. And this is what we call the escape velocity. So this thing here, I think from Star Wars, I've not seen the film, so I don't know which one it is. I don't know what the hell this is. Anyway, basically, this thing here, we're going to launch it vertically upwards to try and get it to escape the gravitational pull of a planet. So here we have the planet of mass m, radius r, and we've got this object here, the spaceship, which has a mass little m moving at a velocity v. Now basically, if v is too small, it's like throwing a ball up into the air. If you throw it up, it kind of gets so high, then it falls back down to ground. If you throw it with a higher velocity, it can get higher up before it kind of then returns. But if you throw it really fast, you get to a point where actually it can just kind of move off into space. So we can think about the kinetic energy. Now the kinetic energy Ek is equal to a half mv squared, and provided this kinetic energy can overcome the energy due to the potential energy, we can say that the potential energy is equal to gmm over r. Okay, and that's the sort of the size that it has to overcome. What we can then do is, provided this kinetic energy can overcome that potential energy, then we get rid of the m's here, and if we rearrange to make v the subject, we can say that v is equal to 2gm over r square rooted. And this is then the escape velocity. So this is an object just being moved vertically away from the surface of that planet. Provided the velocity is bigger than 2gm over r, it can then escape the gravitational pull. And if you put in the numbers, so g is 6.67 times 10 to the minus 11, the mass of the Earth and the radius of the Earth, you should remember these two numbers. So we're talking about 6 times 10 to the 24, and the radius is 6,400 kilometres. If you put the numbers in, you should find that for the Earth, v is about 11.2 kilometres per second. Okay, so pretty fast, which is why we need a lot of fuel and a lot of energy to actually get these things out into orbit. So basically, this thing here is the equation to work out the escape velocity of an object as it moves away from a planet.